Okay. So now comes the part where I actually have to do the traveling salesman problem. So some things I'm going to need to do to actually complete this problem. I'm going to need to have some sort of list of all the nodes in the current path. So I'm going to need an array list. I think I'm going to do an array list of nodes, and then I can just get the strings off of those. Another thing I'm going to need is an array list of paths, because there may be multiple paths through the grid, and I'm going to need to be able to figure that out. So I needed an array list of array lists of nodes, and those will be my completed paths. So let's go and put those two in. Well, the array list of paths I don't necessarily need, but I will need the array list of array lists of nodes. I think I'll call this completed. And yes, indeed, we have gone into the second dimension, for those of you that are paying attention. All right, so here we need to actually call the traveling salesman itself. So we need to get the node that corresponds to our text field. So if I look at this, I need to be able to get the node that corresponds to this, and that's going to get passed in to our traveling command. So I'm just going to call this traveling for now, and we'll fill in the details of it in a moment. His goal is to basically go walk through all the paths and eventually put them all in the completed array list. In theory, I could make it a return type here, but I'll just make it a global variable for now. So things that the traveling salesman needs to know. He needs to know, okay, so to begin with, if the number of nodes in the path is the same, well, is equal to the number of nodes, so in our whole graph, that means we've visited every one. So if we have a path and it's exactly the same number of nodes as our whole graph, we know that we're done actually. Add this path to the completed list. Return. There's something else we're going to have to add here in a second, but I'll get to that in a moment. Otherwise, notice I'm using pseudocode here, and yes, indeed, I'm not going to actually spell it out for you, so too bad. This will give you the algorithm that you need, the step-by-step process, and hopefully you'll be able to figure out how to translate that into the actual Java code. So if I have more nodes to walk down, what I'm going to need to do is get each of the edges. So see if they are connected to the current node. So we're actually going to have a current node that we're passing in. Not. So if they are connected to the current node and they're not already in the path, because we're not allowed to backtrack, we're going to call traveling again on the connected node. We're probably going to have to pass in the path, and we probably need to actually have our total as well. So I think that we're going to have to worry about passing in a number here as well. So we're going to call traveling again in that case. Because we're in a for loop, what will happen is it'll basically pause here. So let's say we're on our first node. We'll pause here. It'll call traveling again with the new node, have it included in the path. So we probably should add node to the path before we do this. And then it'll call that on that node, which will add all of its edges, which will call it on each of those edges. And basically, what we're doing here is something called a depth-first search, where we're actually going to try and find a complete path by walking as far as we can into the graph. And then what will happen is, if it can't find a way out of there, this for loop will end, and it'll go back to the previous call of traveling. So it'll basically back up until it finds another edge from that for loop and walk as far as it can down that path. So it's going to go as deep into the graph as it can each time. This is different than our checking that we were doing before to check to see if we had a completed graph. That was a breadth first search, where we were actually taking basically one step from each node, putting all the edges in, and then from each of those edges, finding all of those edges. So we're actually like taking one step, then 2 steps, and 3 steps. That's what the checking was doing before, the connections. This is actually a depth first. It ends up mattering, and you'll likely hear those terms again later if you are doing more graph theory. So it looks like we're going to need to have some things as parameters. So we're going to need a node and an array list of nodes, path, and an int, which is our total so far. So I'm going to need to have those things when I call it here as well. Let's see. The array list is going to get thrown away. So let me start on the second parameter first, actually. So I'm actually going to create one on the fly. There, that's a path. The total initially will be 0, and then I need to figure out what the current node is. So the thing that goes here is going to be whatever's in the text field except as a node. Fortunately, GraphPanel has something that does that, I believe. There it is. So if I give it a string, it'll get the node for me, as long as it's not null. So panel.getNode for the text out of salesman start tf.getText. So what this will do then is it'll go get that text, look up in the node list for the matching node, and return that here. I probably should be checking to see if it's null before I do this. I should probably have an if statement that says if it's null, then that label's invalid. In fact, let me do that real quick. So if that's not null, then do this. Otherwise, we should probably say something like not a valid starting node. There we go. And I should probably do the proper number of parentheses. That would help too. So if that's the case, we're going to do the traveling. All right, so now we have our initial node, our array list, which is something that's actually created within traveling. Out here, it doesn't actually even have a name, but it's not going to end up mattering because it'll end up in completed if it's correct. And we start off with 0 as the total cost. So if our path is equal to the number of nodes in our node list in panel, we'll probably have to be able to get that. Then we're going to add this path to our completed list. So we can just say completed.add path. I'll get to this step in a sec, and then we'll return. So if we have a complete path, we just go back. Otherwise, we're going to do a for loop through the edge list. We're going to check to see if they're connected with the current node. And if they are not already in the path, then we add the node to the path and call it again on that new node that's we're looking at. We're also going to add the edge cost to our total.